Hey, pre-calc students, this is Mr. Mitchell here. We're going to take a look at logarithms, logarithmic functions and their graphs today. So we have some properties up here that you can take a look at. Ask any questions you need to ask, but they're important things that we need to be able to use. I know they might look a little confusing, but once we get into using them, they make more sense. So use the logarithmic inverse property to evaluate each expression. So what you want to do is try to convert it into an exponential equation. So we're going to change it from 2, the changing formula. We take 2 to the x equals 32. So what does x have to be to make that statement true is kind of what we're looking at trying to answer. So 2 to the 3rd is 8. 2 to the 4th is 16. 2 to the 5th is 32. So that's kind of what we're trying to do with these. You're trying to use the inverse property, which is what we're using, to try to solve for x. So 3 to some power equals 27. So again, you take this number as your base, that's the power, and then it equals that. So that's got to be 3. And then over here, 4 to some power equals 2. So what are you going to take 4 to a power of to get that to be 2? That's going to be the 1/2 power. It's a square root. The square root of 4 is 2. Square root is a 1/2 power. So we've got to know a little bit about our exponent rules here. So 10 to the x equals 1 over 10. So how am I going to make that into 1/10? 10, well, that's a negative exponent. Negative exponents flip. Okay, we're trying to remember some of our exponent rules from Algebra 2. So any negative exponent, you have to end up flipping. So 3 to some power gives you 1. So what power does 3 have to be to make 1? 0. Anything to the 0 power equals 1. And this last one, 2 to the x equals 2. X has to be 1 to make that true. So again, we're using, I've heard teachers call it the wagon wheel, call it a lot of different things, but it's really the inverse property. So here it is listed up here in terms of what property it is. If you don't know that it's the inverse property, it's okay as long as you can do it. So here we go. Evaluate each logarithm with a calculator, rounding to the nearest 1,000. So let's go to our calculator. So what was it? 2 times, now these are all log base 10 questions, I believe. So notice log base 10, log base 10, log base 10, just looking at A, B, and C. So when you type the log in here, it is automatically base 10. If you want a base of something else, you have to do something different. So if it's log base 10, you're good. It's automatically log base 10. So what do we got? 0.796. 0.796 there. So this one is 0.796. Okay. Now we can do log base 10 of -2. So come back over here. Log of -2. Doesn't like that. What does that mean? Can't do a log of a negative number. We'll find that out when we look at the graph. That's not in our domain. So it's not that we typed in anything wrong. We could say a bunch of different things, but this is a domain restriction. And then we have log base 10 of 1/3. Let's go back to the calculator. So log of 1 divided by 3. -4.77. Wrong document. -0.477. Having some issues there. There we go. Okay. All right, example 3. That's not it. Use simple properties of logarithms to simplify each expression. So we want to try to simplify these logarithms by using some of our properties from up above. All right. All right, sorry for the pause there. Getting back to what we were working on. So we're looking at these properties here, and there's different ways to do them, but if you know the property, it makes it really easy to look at. Like there's no work to do. When you have the log of some base of 1 equal to what you don't know is x. Anytime you have the log of something like this, that is just going to be 0. So when I look at my properties up above, that's this one. The log of some base, log base of something of 1 equals 0. And if you do the wagon wheel or whatever you want to call it, it shows why it equals 0. Okay? So then we have log base square root of 7 of square root of 7. So we're trying to find out what this equals. So that's another property. The log base of a number, log base something of the same something equals 1. And you can see if you wagon wheel it, it equals 1. So in this problem, x equals 1. And again, you can do wagon wheel to see that, but we're trying to use properties here just to see what's going on. And then for this one, if you're trying to figure out what it equals, so you have an exponential equation or expression of to a power of a log with the same base of then some number. So let's go back up here. I know I'm scrolling a lot. So log of some base to a power of x equals x. So that's really the same type of thing that we're dealing with right now. So the answer to this is just 20. Again, knowing your properties can save you a lot of work. If you don't know the properties, you can get away with certain things. Like you can do wagon wheel here. You could take the log of both sides once you know certain rules about logarithms and things like that. But knowing the properties makes things a lot easier. So one-to-one properties, again, going back up here, let's scroll. One-to-one property, if you have the log base of some number equals the log base of the same thing of another number, well, the two numbers x and y are going to be equal to each other. When I come back down here, log base 3 of x equals log base 3 of 12. Well, the only thing that x can be to make that statement true has got to be 12. That's one of those properties. All right. Here, the base is 10. We don't write the base 10. I know we did on that first problem earlier, but we're not going to write that anymore. It's not on the calculator. We just have to know that if you see log with no base, there's a 10 there. It's kind of like x to the first power. Nobody writes x to the first. They just write x. Everybody's supposed to know that it's got a 1 up to it. So you have two logs equal to each other with the same base. You just say that what the of part is equal to each other. So when you solve this, you just get x equals 1. And then same thing over here in letter C. You have two logs equal to each other with the same base. So then what they are of is equal to each other as well. And then you just have to solve it. So x squared equals 16. You take the square root, x equals, be careful, plus or minus 4. All right, so knowing that property there again also helps us. All right, so now we're getting into graphing. So we should know what y equals 2x looks like. Let's graph that in red to start. So y equals 2x, our exponential equation goes through 0, 1. It's going to give us a horizontal asymptote at y equals 0. It's going to kind of look like that. So we're going to have a logarithmic function that is an inverse. And if you recall, you find an inverse graphically, it's reflective over the line. I know that's not a great line, y equals x. So if you reflect it over the line y equals x, it should come down here. And it does. Let's take a look at what it's going to look like in terms of a graph. So if we just, I'm going to graph log base 10 just to kind of show, I don't want to try to teach two things at once because I have to show you how to do the change of base formula to do log base 2. But if we graph this, change our window, that's from another class. Anytime your window's messed up, you want to change the mins to -10 and the maxes to 10. And then you're going to graph it. So that's what the graph looks like. We're just looking at the general shape. So what this graph actually gives us, we're going to have a vertical asymptote at 0, x equals 0. This graph actually does continue down here. It never stops. It goes down. Oops, not trying to do that. It continues down here. We don't have very many graphs that just all of a sudden stop. Remember, this is a calculator. It's not an LCD TV, 65-inch TV on your wall at home or something like that. So this graph comes down this way. Okay. So going back to our graph here, graph it in black. So it's going to go through the domain. We're going to have a domain restriction. We're going to go from 0 to infinity. We can go to the right forever, but we can't go left forever. Can't plug in negative numbers. The range, you can get anything you want in the range. The x-intercept is 1, 0. It doesn't cross the y-axis, so we're going to have a vertical asymptote here at x equals 0. And you're going to go through the point 1, 0. So it's going to look something like this. And you know, I tried to make that as close as I could. It's reflection over the line y equals x. So the red one, if you fold it over this line, you get the black one. So there's an asymptote at x equals 0. And it is an increasing function. It increases very slowly, but it does increase. Doesn't matter how fast something increases, it is definitely increasing. As you go to the right, what does the graph do? It's going up, just goes up very slowly. So logarithmic growth would not be something you'd want to put money into because you need a lot more time to go by before you make any money. You'd want money in your exponential growth because as time goes by, it grows faster and faster. That's kind of the difference between the two graphs. Okay. Next part says evaluate each natural log with a calculator. So natural log is just a different base. So a natural log, its exponential partner is y equals e to the x. We looked at e to the x when we did exponential equations. These are just inverses. The natural log and e are inverse equations of each other. So we need to evaluate some equations. The natural log button is on our calculator. Notice if you hit the second button, it goes with e to the x. So, sorry, I forgot, what are we evaluating? E, natural log of 2. So we'll take the natural log of 2. So 0.693. So let's record that, 0.693. And then let's evaluate the natural log of -1. Maybe you know what's going to happen here. Maybe you don't. Natural log of -1. And nope, can't do it. Go back to your domain. Go back to your domain. I can't plug in negative numbers. I don't cross the line y equals x. I can't do that. So this is another domain. Sorry about that. Domain restriction. And then I need to evaluate this. Okay, 1 plus the square root of 2. I know it might look ugly, but it's just a calculator question. Natural log of 1 plus square root of 2. 0.881. So 0.881. Okay, they're calculator questions. Just type them in. All right, last section are properties of natural logarithms. They're very similar to any other log property, but again, we can scroll up, take a look at some of our properties. Natural log properties, the natural log of 1 equals 0, the natural log of a, natural log of base a of a equals 1, the natural log of e to the x is x, and the natural log of x equals the natural log of y if x and y are equal. Okay, those are all properties that we can use. You know the properties, you can skip some steps. So the first thing you need to do here, we don't evaluate things that are fractions with logs. This is actually e to the -1. How do I know that? Exponent rules. I can rewrite a fraction without a fraction if I change the bottom exponent, excuse me, to -1. So the answer to that is just -1. So what's e to the natural log of 5? Well, e and the natural log are canceling each other out, just kind of like they did over here. They're canceling each other out, so that's another property. That's just 5. So what's the natural log of 1 divided by 3? Well, was that one of our properties up here? If not, we can type it in the calculator. Natural log of 1 is 0. Okay, so I have natural log of 1, which is 0 divided by anything. It's going to be 0, whether it's 3, 33, 100, doesn't matter. And then what's 2 times the natural log of e? Remember we said the natural log of e cancels out. So that's just going to be a 2. All right. So these are some of our properties for logarithms. These are some of our graphs. Thinking about exponential equations, they are inverses of exponential equations. Logarithms and exponential equations are inverses. They're opposites. So everything is flipped. Everything is reversed. The domain and the range, they flip. Properties are very similar, but they're kind of backwards a little bit. But if you have any questions, let me know.